Nuclear Fission by Jacob McCleary. What is nuclear fission? Nuclear fission is what is used to create nuclear energy. When a nucleus fissions, it splits into several smaller fission products. These fission products are about equal to half the original mass. However, there is about a 0.1% difference between the mass it's supposed to be. That's called mass defect. This is explained by Einstein's famous equation, E equals mc squared. The E stands for energy, the m for mass, and the c for speed of light, which is 3 times 10 to the 8th meters per second squared. No one knows why the mass is different than the expected outcome. 2 or 3 neutrons are also emitted. How does a nuclear power plant work? A nuclear power plant uses uranium as a fuel for this large nuclear furnace and cadmium control rods to keep the uranium from making a nuclear chain reaction blast. The cadmium control rods can do this by absorbing neutrons that go flying through the reactor vessel, in return limiting the amount of nuclear fissions. By doing this, they can control the amount of power that is supplied to them by pulling the control rods out a small bit for more power and vice versa for less. As the nuclide fissions, this heats up the water that flows in a generator nearby, creating steam as it moves. This steam is then forced through a turbine, creating electricity in a nearby generator. The steam is then condensed and cooled off, ready for another cycle. Why don't we use it instead of other forms of energy? Not only is producing a nuclear power plant costly, it also creates an excess of highly toxic radioactive waste. This particular waste won't break down for millions of years, possibly even billions. Also, a crucial part of building a power plant that won't melt down is the presence of large quantities of water to cool the system down. Chernobyl was a famous case of a nuclear meltdown, and it all started because when they shut down the systems and didn't account for the steam to build up and explode, thusly breaking the radioactive elements out of their shielded containment and forcing it out into the surrounding areas. Below is a picture of Chernobyl. Chain reactions. As a nuclide undergoes nuclear fission, it splits into 2 smaller fragments known as fission products, along with the 2 new smaller and lighter products. Few neutrons escape and travel in a straight line with extreme force. As these neutrons travel, they will eventually reach another nuclide and split that one in half, creating the 2 fission products and sending a few more neutrons on their ways. As you can see, a pattern is being made, and where we started out with 1 or 2 neutrons propelling themselves around to maybe 6 and then 12, and so on until a huge chain reaction is reached. That is nuclear power behind the atomic bomb. How do we control this power? Now, nuclear fission can't be used for energy, simply because not enough of these reactions are taking place at the same time. However, we can dampen the explosive effect of nuclear fission by introducing the cadmium control rod. Every nuclear reactor has to have this crucial item, due to the sole fact that if it didn't have these control rods, every time they would start up the generator, the whole lab would explode in a fiery nuclear blast. These rods act almost like a reverse battery. They absorb a certain percent of the neutrons that are whizzing around in the reaction chamber, and then for every neutron that they can neutralize, that's 1 less nuclide, splitting into multiple neutrons. However, the cadmium rods also need to be replaced from time to time, for they can only absorb so many neutrons until they become useless. The process for switching these cadmium control rods is a very simple concept, but is actually extremely dangerous to perform. The rods need to be extracted one by one, and ensuring that the reactor is fully shut down, the steam situation won't get out of control, such as the Chernobyl. Nuclear fission won't become so potent that it explodes. The below is a picture of a cadmium rod. What do we do with the nuclear waste? We basically end up putting it behind an ice chain fence and eventually build a radioactive landfill once we get enough of the radioactive waste. Rad waste builds up. Although many arguments have been made on how to get rid of the waste, such as shoot it up into outer space, which is too costly for the amount we produce, or let's try to shove it under a carpet and hope that its radioactivity will go away, which eventually, after millions of years, will. All in all, many scientists are still trying to find a good way to recycle the waste, or just find a good way to make it disappear. Nuclear energy and what it's used for. Basically, nuclear energy is used for electricity and thusly will supply power for anything electricity can. Nuclear energy is also used more in the form of a nuclear bomb. However, due to the concerns of just how dangerous nuclear capabilities are, the nuclear proliferation laws were passed, stating that we can either lead by example and disarm ourselves in the hope that others will follow, or we can seize all other forms of nuclear energy from other foreign countries. Nuclear fission is not the same as nuclear fusion. Some people may get the 2 confused. However, unlike fission, fusion doesn't leave rad waste all over the place, and is a cleaner option. Fusion works by smashing the 2 nuclei together, and the sun uses this form of nuclear power to keep on burning bright. Fusion uses helium, whereas fission uses uranium and other radioactive components. At the end of it all, fission splits nuclides by shooting neutrons at it, whereas fusion crashes 2 nuclei together. It is very important not to get the 2 confused, because one produces an insurmountable amount of rad waste, and the other is a cleaner, more efficient choice, despite not being able to heat water up as much, resulting in its unusableness. The end.